right. Welcome, everyone, to this Ask Me Anything session on our recent open source initiative from NIL. I'm Dennis. I'm a DevRel here at NIL, and I'm very happy to introduce you to Alexander and Aleksa. We'll be running through our code base and in particular how our network works. Before we go into the details, please do share this with your buddies and with everybody out there if you think they'd find it interesting. And without further ado now, Alexander, could you give us an intro of yourself, and then let's dig right into it. Thank you.
Sure. Hi, everyone. I'm Alexander. I work at the cluster engineering department of NIL. So we develop the nodes themselves, the validators, the archive nodes, the RPC nodes, etc. that you can use to run a validator, run your own testnet at this stage of the project. And I'll be sharing a little about the architecture of the network at this stage, the interaction between the various nodes, and hopefully we can launch our own DevNet and have a little fun with it. So let me share this scheme. And this is a diagram that should make everyone familiar with the structure of the network as it currently stands. So we are launching as an L2 network, and we're a sharded network, which means that the execution is split into various shards, which interact with each other using messages instead of direct calls. And as we are a zk network, we'll be connecting to the L1 network of Ethereum via a proof infrastructure, which consists of a sync committee, an observer fetching new blocks from our network, an aggregator, which integrates them into batches, and a prover that runs the actual maths, the zk proofs, that can be later committed to the L1 network via a bridge contract. So this is the part, the L2 network part is what we'll be mostly looking at today, and which now runs in the testnet in its ready state. And we'll discuss the prover and the bridging part more theoretically. So each shard of our network is like its own blockchain, like its own Ethereum. In each shard, transactions are run and smart contracts are launched and modify the state of this shard and this shard only. But individual shards can exchange messages so that you can actually influence the state of other shards during the execution of your contract. Okay, let us look at the NIL repository, which went public earlier, like a week or two ago. And let's see where all of those parts live and how we can build the code and run our own DevNet if we want to contribute to the current implementation. So let me share the repository structure. Okay, I'm afraid my Meet page has become unresponsive, so I can't share the repository structure, but maybe someone can do it for me.
Maybe if you unshare and then reshare the screen. Oh, Aleksa is presenting.
Yeah, I'm afraid I can't stop presenting anymore. So I'll rejoin in a moment because I have to close the browser tab.
Sounds good. For those watching, nil is organized as a monorepo. So you'll find inside the nil repository, NIL, so the nil foundation org, all the different modules that are part of what constitutes the cluster or the network. So every component that was in Alexander's diagram just now is in the monorepo, can be found in the monorepo.
Okay, I guess I'm back now. And
that worked.
Here's the monorepo at GitHub/nil foundation/nil. It is actually the basis for all our development, most of our development currently. And most of the parts that I talked about are concentrated in the nil folder, where most of the executables live that you'll want to use. nil-d is the main daemon, which you can use to start a validator, an RPC node, an archive node. The sync committee tree is devoted to most parts of the intermediate layer, the sync committee, which synchronizes the L2 part and the L1 part, which integrates the observer, the batch producer, and of course the prover. So in order to launch parts or all of the network, you will have to refer to the build documentation, obviously, build your own binaries, which will be also uploading and publishing. So in principle, you don't really have to build your own binaries. And then when you have them built, let's switch to the okay. Let's demonstrate building the configuration for a DevNet and launching it. Okay. So this is the monorepo that I'm showing in Visual Studio Code. And we have documentation here on running your own nil-d instances and the configuration that you can start. So you can actually have a DevNet in a single process. If you're doing some simple development and you don't need to test the network parts, you don't want to test remote calls or anything, then you can actually launch a DevNet in a standalone process. And that's really simple. You just run nil-d, you specify the HTTP port for the RPC, and it just basically starts a DevNet in a single process. You can specify the amount of shards, where it should put the database, etc. But basically, you're all set. You can use this RPC with our CLI or with Nil.js and run transactions or test the validator in any way that you would prefer. And there is a more complicated setup. If you prefer, you can write a configuration for a complete DevNet with separate validators, archive nodes, and RPC nodes. Specify the amount of each kind of node and how they should be connected. So you can test various configurations and figure out what makes sense for your use case or your development process. This is part of the documentation that comes with the daemon, part of its documentation. So you can write a specification of your particular DevNet and launch it the way that it's indicated in the documentation. You can run each kind of node using its own specific command, and then you're all set. Okay, so let's dig a little deeper inside the implementation of the validator. So as you may know, Mil is an EVM-based network. So basically, mostly compatible with Ethereum for many kinds of contracts that you would want to launch. And adding more capabilities with regard to messaging between shards, actually sharding, etc. So the execution part is very similar to the Go Ethereum implementation. And if you are familiar with Go Ethereum, you will feel right at home. Right, the execution comprises an EVM with the usual operation codes and their usual semantics corresponding to some release of Ethereum. The consensus folder comprises our implementation of the consensus, currently running in the test nets to a limited degree. DB is our database implementation, a local database on the validator comprising storage. And yeah, the names of the folders really speak for themselves. So there's a network implementing our custom network RPC protocol, the interaction of the validators in the network. And there is a JSON RPC that's basically similar to Ethereum, although not completely compatible because, of course, we have sharding and we have to specify the actual shard that we want to run our transactions in or the shard that we want to read the state of. Okay, so other binaries that you can find here are obviously the sync committee implementation, the prover, the patcher, etc., that you are unlikely to want to run by yourself at this stage. Yeah, that's basically what I wanted to say about our open source repository and the structure of our network. So
I have some questions here for you,
sure.
Alexander, before we move on to Aleksa. How can folks that have a chain with a different execution environment attach the prover or the proof system to their their implementation?
This is going to be tricky at this point because the first consideration that you have to take into account is that our proof system is not really a general purpose proof system. It's highly tailored with its circuits, with its math to our specific network. And so to attach our prover to another system, it would be necessary to develop new circuits, which is a highly involved process. You would need tools for debugging those circuits. You would need to understand how those circuits work. So this could have been a separate startup all in itself. So the proof system as it currently stands, there are generic components that you can extract from it and reapply it to a different method. But that's a lot of work.
If a project would like to use some module from the code base, what licensing is in place?
The code is all licensed under the lesser general GNU public license, lesser general public license, LGPL, similar to Go Ethereum, similar to Aragon and many other projects. So basically, you have to keep it open source and keep to the spirit of LGPL, but otherwise you're free to use it, redistribute it, modify it, etc. So it's quite fair, I would say.
You've run through how we can run the wallet or the node locally. Can we attach it to testnet?
Not really, no. The testnet is fully permissioned. We run all of the nodes ourselves. So you can expect the ability to join the network as a validator sometime after the mainnet launch, when it becomes less of a permissioned setup, but definitely not now, and definitely not at the start of the mainnet. So not yet.
Amazing. And what are the hardware specs for running a node?
Well, at present, this is mostly moot because you can't join the network, so there are no specs and no requirements. You can run a DevNet on a toaster if you prefer, but in the future, when we have a mainnet and you can join it as a validator, definitely not a more powerful node than on Ethereum for the same amount of transactions, because the architecture of a single shard is the same and the requirements are basically the same, and we even are at an advantage here because we have less storage, less historical data. We don't have blobs for higher level networks to connect to us, etc. So, and if the specs have to grow, if there are more transactions, then we can handle with those specs, then we can add more shards, distribute the load. So the answer is, for the same amount of transactions as an Ethereum, not larger specs than for an Ethereum node. Basically, that's what we can say for sure.
Horizontal scaling. Great. Thanks, Alexander. Anything else you'd like to add?
No, not really. I think that's all.
I have one thing to add. I think it's also important to highlight that even though you cannot run the validator node currently, we are actively working on opening archive nodes. As we know that most of the partnerships, for example, people who wants to build indexers and whatnot, they will need these archive nodes. So we do have a concept of archive nodes, but we are still working on opening it. And once we do, then anyone would be able to just start the archive node and use it for, querying, sending, and so on.
Cool. So moving on, Aleksa,
Okay.
we have a bunch of dev tooling. We have some exciting end user products that we released recently. Why don't you run through these for the audience?
Yes, we do, and we are really proud of them. So basically, Alexander, as someone who represents the core product, he focused mostly on this nil repository, which is again where the whole everything related to the protocol is. But we also understand that as we are kind of the new ecosystem and we are building many start from scratch, and we are not fully compatible with, we changed some things like some RPC methods and then whatnot. So you cannot just hook any integrations. So you cannot just use the MetaMask and connect to it. You cannot use different toolings. So we as a company, we understand that we need to provide some of these things so developers can start building. So and we decided to put everything in a single place. Thus, we have this big monorepo. And also, I think it's important to touch bases why we did it. So we feel that these necessary integrations, and I will go over some of them, so needs to be always functional and up to date. And as we are currently in a testnet, some things are changing. So, but we still want to make sure that the things that we deliver, that we stand by them and we know it will work with every new release. So we decided to go with this monorepo approach, where we added a bunch of automated tests, where, for example, if Alexander wants to break something, if he changes something in the protocol that influences other integrations, he will not be able to merge a PR until he fixes everything. And by doing all of this, we just want to make sure that from release to release, we are not breaking the stuff, and that everything will continue to work, and that we just add the new features. So we have a bunch of folders here, and I will cover a couple of them, which are probably the most important. So the first and the biggest thing that we have here is our JS SDK. So basically, we have a library for interacting with the network. So think of it as Ethereum has VM, Web3.js, and so on. So we took the part of VM's architecture and we just adapted and created our own. The reason for it, again, as I said, even though we are EVM opcode compatible, you cannot use the existing libraries to interact with the network. So we had to build our own. So if you want to basically do anything from your dApps and so on, you should always go and use nil.js. So it has a lot of great features, from how to deploy the contract to how to interact with the network, querying the network, and so on. I don't think that we should go much more in detail. Documentation is quite good, so you can always go there and just figure how to set up. And basically, this nil.js is the backbone of all other integrations. So if you want to see how to use it, you can always go to some of other integrations and see how we use it, how we used it to do something. So also, we know that some people like CLIs. So we did develop our own CLI. So it has a similar purpose as the nil.js. With the nil.js, you need to write the code, you need to, set up something, run, and so on. But the CLI is giving you probably the fastest way from the terminal just to do the simple tasks. So you can, again, from deploying the contract to interacting and so on. Initially, we wrote this with a Go, and we had a fully separately Go CLI as well as nil.js. But then over time, we realized that we want to make sure that this nil.js really works. So we are now currently working on moving the CLI from the Go version to the JS version. This JS CLI is utilizing under the hood nil.js. And by doing that, it's basically testing and making sure that everything works. So besides CLI and nil.js, we also have something we call Playground. We shared it and we are sharing it everywhere. So this is basically, so these are these two folders, so backend and the frontend. And there within the Explorer, you have the Explorer. So we built our own block Explorer. You can query, see everything, what's going on, search the transactions and so on. But we also have the sandbox itself, meaning that there you have the online ID that you can just open and work and deploy the contracts. So on more user side, we are also working on our own wallet extension. So we still don't have it published. I hope that by the time this recording is published somewhere, we will already have it. But if you want to go and yes, so if you want to go and just test out the wallet, you can always build it locally and import it in Google Chrome development extension tool. So, but as I said, we are working on publishing it soon. So regarding the question, so Nil.js as other SDKs, other libraries, it's mainly used for interacting with the network. With Nil.js, you can, first of all, work with contracts. So you can deploy a contract, interact with the contract, and so on. You can send transactions, basically. And also, you can use the Nil.js for different RPC methods. So you can query, for example, transactions. So that's basically it, and I hope it answers the question. So besides Nil.js and other stuff that I mentioned, we also experimented a bit with the DeFi. So we wanted to see how the Uniswap can be moved on the sharded architecture. So we did take the Uniswap contracts and we adapted them to work with shards. So, and also I think that this project is a really good example if you want to build something on Nil, how you can utilize the Hardhat and Nil.js and write the contracts and manage the contracts and so on. Because Hardhat is basically just the task management. So you can, in theory, without any issues, just create a Hardhat project, import the Nil.js there, and then create a bunch of tasks for deploying, interacting, and so on. And we always advise people who want to start building something from scratch to go and check out how we did it with the Uniswap, as it kind of shows from start to finish how you can manage and work with the smart contracts in Nil. So I think that this covers it. We also have some others. For example, we have this Create Nil Hardhat project, which is creating the Hardhat configuration for you. And we are working on different examples. So here we want to set a set of different contracts to showcase like what cool things you can build. We are working on extending it, as well as we have the smart contract directory. This is where all the Nil smart contracts are. So here you can see how we created our faucets, how we created our library to call some precompiles. You can also see how we have account abstraction at protocol level. You can also see how our wallet smart account implementation looks. But again, as we have account abstraction on protocol level, this is not the only implementation that can work. I think that we also, in our docs, we also covered multi-sig wallets and so on. So I hope this gives the overview of everything. And I think it's also worth touching the basis how someone can contribute. So once we open source the repository, we also started moving all the tasks and issues open here. So for everything that we do for, let's take, for example, the wallet, you can always go here in the issues. You can search by these tags. So for example, we can go to wallet extension, and here you can see all the things that we plan to add. So we also created this good first issue label, so we need to add more. But basically, good first issue is for if anyone wants to contribute, you can just search these and just assign it to yourself, and then open the PR, and we will review it and hopefully merge it. And in that way, you can contribute to the whole ecosystem and the protocol. So yes, and also we plan to publish the contribution guide. So we did open source the code 2 weeks ago, but we're still currently writing the whole contribution guide, which will, everything that I just said will just explain a bit better. So I think that's it, Dennis. I hope I covered everything. If not, please ask.
I think we have a couple more questions from the audience. I read here, for the wallet, how does it connect to contracts? How can this support account abstraction?
So the implementation that is currently written is just the first MVP. So it has the basic wallet functionalities. So anyone can just start the wallet. It creates automatically a new smart account. It has a way to topping up the currencies, both the default currency as well as all others. And currently, one of the issues that exist in our backlog is this one wallet extension SDK. So we want to follow the same road as other wallet implementation Ethereum did. And we basically want to create an SDK that anyone can use and basically connect to the extension itself, as well as, if needed, request to sign the transaction and send it over the wallet, so you don't need to expose the private keys anywhere in your app. So it's work in progress. We do hope to finish this relatively soon. So yeah, once we do, we will write more about it.
Amazing. I see a new question here coming up. Does nil shards have all the required precompiles to verify Groth 16 proofs? I think that's more a question for Alexander.
Well, I don't think I'm ready to answer that, really. Guys, if someone could tell me what precompiles those are, then I can definitely tell you what precompiles we have. Right, and it's all of the precompiles currently in Ethereum. So, and with some of ours added, obviously, for cross-shard messaging, etc. So if Ethereum has them, then we have them too.
And we will also answer this question async in chat. It's worth checking.
Cool. Anything else you guys would like to add? Any of you? I think this was a very informative chat. And thank you, everybody, for assisting. And we can always chat async. By all means, do also check out our website. Our website has a direct link. The website is nil.foundation. It has a direct link to our Telegram bot, which has a link to our developer community chat group, and also gives you access to testnet, giving you a customized RPC URL so you can interact with the network, and many other resources. So do find us through there. Once again, thanks all. See you around. Thank you.